Hello everyone, welcome to this video. In this video, we will be talking about bidirectional search in artificial intelligence. So talking about bidirectional search, it is also one uninformed search in which we do not have much heuristics about the problem space or the state space. It is a very special type of search because here two simultaneous search takes place. So there are two simultaneous search which takes place here in both the directions. What directions we will be talking about in detail. So two simultaneous searches takes place. Now these two simultaneous searches would be one which is known as the forward search and the other one which is known as the backward search. Now forward search is basically from the initial state to the goal state, initial state to goal state. However, the other one which is the backward search, this will happen from goal state to initial state. However, one factor that we have to remember is that we should have prior idea about the goal node. So this bidirectional search, it runs two simultaneous searches which we already discussed. It is known as the forward search and backward search, and both of these searches are done so that it achieves the goal node with the minimum time complexity or with the minimum amount of time involved. Now in order to realize this, we have to divide the search graph into two small subgraphs. So search graph is basically divided into two small search graphs, into two small subgraphs. So these subgraphs will be helping us to implement the forward search and backward search. And in these two subgraphs, in one we will have the forward search and the other one we will have the backward search. And what is the stopping condition? The graph or the search stops when both the searches or both the graphs, they intersect with each other. Okay, so it stops when the searches intersect with each other. They meet at a point, basically intersects with each other. So we will see this with an example, so we do not have to bother about it much now. And also both this forward search and the backward search, both of this, they can be in any form that we have already learned. That means it can be either a BFS or a DFS or a DLS, anything. Or we also have uniform search cost if there is cost associated with it. So all those searches will be there. So it depends entirely on whatever searching technique we would like to use. So now let us simply talk about the advantages and disadvantages of it. So initially, talking about the advantages, first advantage would be it is fast. It is fast because the search does not need to be throughout. That means it would, suppose let's consider that you have to meet a friend. So the friend's house is somewhere here at this point, and your house is somewhere at this point. Now if the aim is or the goal is to meet your friend, either you can move to your friend's house or your friend can move to your house, and the other option can be you can ask your friend to start from his house at a definite time and progress towards your house, and you also can start from your house and progress towards your friend house, and both of you will reach a common point in which you can meet each other. So in this way, what happens, the entire route does not need to be traversed by any one of you. Okay, so both of you will take one step towards each other, and you will do not need to traverse the entire search space. You can just simply meet at the intersecting point. So definitely it is faster. The next one is bidirectional searches, they require less memory. So since we do not have to traverse, or we do not have to generate the adjacent states at each point of time, the number of nodes are generated less, and that is why the less memory would be occupied. However, there are certain disadvantages also, and disadvantages can be in terms of complexity in implementation, because it is difficult to implement. So complexity in implementation. And the second one is that we definitely have to know about the goal node. So information of the goal node should be there. Information of goal node should be there. So in this case, we will not be considering any spanning tree as the output, but we simply would be associated with finding the goal node. So goal node should be available. So these are the two main disadvantages of the bidirectional search. Otherwise, it is a complete search on its own. And for this, now let us consider a small example. So suppose I have a graph something like this: 1, 2, 3, then this is connected to 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So suppose we have a graph something like this, and this is, let's say, the initial node. Initial node is 1, and 15 is the goal node. Now forward search will take place in this direction if I am using the depth first search, and finally will reach up to 9. Okay, so basically if I'm considering the 8 as the midpoint, okay, so if I'm considering 8 as the midpoint, so this will be my intersecting point. Here I will be considering the forward search, and in this part I will be considering the backward search. So when I'm considering the forward search and backward search, I have to also consider the intersecting point. So this is the intersecting point. And now what happens is, the forward search, it will take place across this direction and finally would reach up to this level. Okay, again the backward search, which is starting from the goal node, it will also take a similar approach and it will reach up to this level. Okay, so what happens is that the entire path does not, or entire search space, it does not needs to be traversed. So what happens is, the time complexity which is associated with this is basically, so for forward search, if we are considering the depth to be d, the depth of the entire search to be d, so it does not need to traverse the entire space. So the depth finally will be converted to d by 2. So the time complexity of the forward search will be b to the power d by 2, and also the backward search also will be the same thing. That means we do not have to traverse the entire search space and it will be divided. So we will have b to the power d by 2. So the total actually would be, so this will be traversed in b to the power t by 2, and this would be traversed in b to the power d by 2. So we have to add both of them, and it becomes twice b to the power d by 2. Now this can also be represented in the form as, this 2 can be removed and it can be represented in the form as the worst case scenario, which is b to the power d. But however, in order to make it more understandable, we will consider that it is twice b to the power d by 2. Similar is the case for time space complexity. So it will be also the same thing, but it has to be represented in the d to the power 2 d by 2 format, because the depth that it has to traverse is not the complete depth of the entire search space but half of it. Okay, now talking about the completeness. So this bidirectional search, okay, bidirectional search is complete if we use BFS. Complete if breadth first search is used in both these cases. That means the search which is happening here, that is also breadth first search, and this is also breadth first search, then it is optimal. That means we will get a complete search here. Okay, but if we use depth first search, it might not be a complete one. Let me give you a very generic example. Suppose now, if suppose your friend and yourself, both of you are traveling through two parallel roads in order to meet each other. So your friend is traveling from this point and you are traveling from this point. Now if these two are two parallel roads, then the entire road will first be traversed until it reaches the end, and then it will be backtracking and moving to this direction. Similarly, for the other one, that is yourself also, you need to traverse through the entire path. Okay, suppose this is the starting point and this is the goal maybe, and for this person this is the starting point and this is the goal. So it has to traverse through the entire distance first, and then it will backtrack and it will go through a different direction, right? So it will never be able to meet in between if you are using DFS. However, if I am going for BFS, then the search will happen in this direction. So at one point of time your friend will be here, in the other point of time it is here, then at this point, then at this point, again at this point, and at this point. Similarly, yourself also will be moving in this direction, and finally you will, both of you will meet at a common intersecting point. Hence breadth first search is basically more optimistic and more optimal and complete in nature, apart from DFS in bidirectional search. So we have to be extremely careful in choosing the searching options for the bidirectional search. However, it is considered as one of the most efficient searches considering the uninformed search scenario. So this is all we had to know about bidirectional searches, where two different simultaneous searches occur, that is forward search and backward search. And we need to also but in order to implement this, the only disadvantage is that we have to have information about the goal node. So that is all for bidirectional searches. We will talk more on this uninformed searches in my next session. Thank you.